family just doesn't die.
That would probably have to make it. My mom's mom had it.
Calculator. All right, the first one. If you don't need it, tell me, because I don't want to waste my time working it. Yes, we need it. Okay, so this one asked for MRAM, which is midpoint, right? So it asked for, and if you guys made hundreds or A's or whatever, I'm really sorry. That's lovely. MRAM. So I'm sorry to be on the phone and everything, and I'm done. So it said four rectangles, find the midpoint. So here's what I did. I set up my XY, and I went from 1, 2, 3, 4, 5, because my width is going to be 1, right? But I need the midpoint. I don't need the 1 and the 2. So I just went in between, and I did this. I said 1.5, 2.5, 3.5, and 4.5. That'll give me exactly in the middle, right? And then on my calculator in y equals, I put the function, and then I went into the table to get the values because I didn't want to calculate that for each and every one of them. And when I did that, I found that at 1.5, it was 1.8445. 2.5 was 5.3337. 10.997. 18.746. Those were my heights there. And so then since it was rectangles, all I had to do is the height's the same. It's still, or width. The width is still 1 each time, right? So 1 times, and then I added these together. And you only need them in there 1 time because it's rectangles, right? Yes, and if that width hadn't been 1, it's because the rectangle, remember it's that b minus a over n. So I went from 5 to 1, or from 1 to 5, and I needed 4 sections, 4 rectangles. And you should have gotten approximately 36.91 or 9212. Make sure you show that whole, since it says show the setup and what goes where in the whole process. So make sure you show that you found those points, not just ran the program on your calculator. Remember, you can run that program to check, but you want to make sure you can do it by hand also. Number 2, I know y'all need number 2. Okay, so number 2, first thing I did was I graphed this function in my calculator and I did my window. Do you see under it what the window settings are on this? I always use that, and they'll always give you the window settings on stuff like that. It says 0.6 by negative 2.25, 2.25. So whenever I graph this, I went ahead and set my window to those dimensions. So I'd be looking at the same thing they were looking at. And it just makes life a little easier. So you get a picture that looks something like this. And I shade it in. So the first one, and it says just show the setup and report the value, right? So it wants the integral from 0 to 6, which is this whole integral of 0.2x squared minus 0.8x minus 1 dx. And this is just on your calculator. You could either put y1 and then on the graph go second calculate, and I think it's 7 maybe for the integral, and do the integral that way. Or you can do the, like we did the end deriv, you do the end integral. Y'all need me to show you that? Y'all remember how to do it? This is part A. And if you go through all that, I think you get negative 6. Okay, so you could have done antiderivative and you could have gone through, and you would have gotten the right thing. It was just that this was a calculator problem and it said I could use the calculator for it, so I didn't. But if you did it, so you would have 0.2 over 3x to the third. Show how you set it up to find the integral, but you don't actually have to do the. Now, if it says show the process, like, see the difference in number one, the whole process? That's when I want to show everything. If it just says show the setup and then tell the area, just show what you're finding. And the reason is there's a difference in part A and B and what we're finding here. If you did this, hope you still could have done it. Little more room for mistake here. 6 to the third minus 0.8 over 2, 6 squared minus 6 minus, oh, well, that's going to be 0. And then you did the integral of it. Yeah. Okay. A lot of you got confused on when you do antiderivative and when you don't. So we'll talk about that as we go. So don't let me lose track of time. All right, y'all okay there? Part B, well, it's actually C, is where everybody messed up. Okay, so let me show you what happened. I want to get this and show you. And I made it quick. Where are we? 0.2x squared minus 0.8x minus 1. This is where I told you I'm setting my window. I'm still set here on a trig window, but I'm setting it to what they have, negative 2.25. Oops. So because it asked me to find area, area has to be positive. So as I look at this, I've got a lot under the curve that's going to be negative, right? So I need to know this point so I can split this up into two integrals. So I can do the absolute value of this one plus the actual value of this one. Okay, so to do that, I'm going to go second trace, and I'm going to find the 0. Left bound. Can't see my. Oh, I was like, what? Come on, little spider. Right bound. So it crosses at 5. So what I'm going to do whenever I do this interval or this integral, I'm going to do the integral from 0 to 5 of y, but I'm going to do the absolute value of it because it's down below the x-axis. And then to it, I'm going to add the integral from 5 to 6. So I'm going to have to do both of these on the calculator to find the area. So second trace, this is my favorite one to do because it shades for me. From 0 to 5, second trace, number 7. So negative 6 2/3, but remember I'm going to flip that because it's area. Now if it asks me just to find the integral can be negative, the area cannot be negative. 0 to 5. So 6 2/3 for this first piece of area. And it's negative, so I'm just going to make it positive. So 6 2/3 here. And to that, I'm going to add, now I'm going to go and I'm going to do the integral from 5 to 6. And I get 2/3. So 6 2/3 plus 2/3 would give me 7 1/3. Or 7.333. Or 22/3, whatever. I feel like most of you got number 3, but most of you got number 3 because you used trap rule program on your calculator. Yeah. So again, for number 3, I utilized my calculator. In y1, I put x squared minus 4x plus 4. It asked me to do the integral from 0 to 2 of that function. Trap rule with n equals 4. So if n is 4 and I'm going from 0 to 2, that means my width each time is going to be what? 0.5 or a half. You're exactly right. So that width of each triangle is 1/2, or each trapezoid is 1/2. So what I need to do, I start at 0, and then I'm going up by a half. A half, 1. 3/2, or 1.5, 2. What am I going? Oh, that's it. But remember, it's a trapezoid, right? So here's a trapezoid. That's 1. Here's the second trapezoid. Here's the third trapezoid. And here's the fourth trapezoid. They share those bases, remember. So now I used the table on my graph. And I got 4, 2.25, 1.25, and 0. So now the area using trap rule, remember, it's 1/2 times that width, or times that height, right? So a half times a half, and then I'm going to multiply it by, I do the first, twice all the ones in the middle, and the end. And if you do all that, you should get 2.75. And if you run it on the calculator, you should get 2.275. If you just run trap rule on that one. If it says show the whole process, yes. But definitely use that rule to check. A is your lower limit, so that's your 0, and B would be your 2. Right. Yeah. I think everybody got number 4. The people that didn't get number 4, I think you forgot to divide by 2. Remember, because it's h over 2. So if it's 30-foot intervals, then in the beginning you have to multiply by 30 over 2. Does anybody need me to work that one? I think everybody got number 5. Anybody not get 5 that needs me to show you how to do it in a calculator? Good. All right, non-calculator. This was the stinky one. Oh my gosh. Okay. Let's see if I can get through it by time. This was my favorite one, but y'all clearly did not like it. If you need it, take Pepto Bismol. Read the bottle and see how much you need to take. Sorry, y'all. Great day. Okay. Use area to evaluate. This one was the one I think only 3 of you got. I was so surprised. Yeah, it was not a lot of people got this one. All right, I've got this function 3x, right? We're just going to say this is 3x. And I've got 2 arbitrary points, a and a squared. And I know a is bigger than 1, but that doesn't tell me the value of a. It just tells me that it's over here. It's going to be positive and past 1. It doesn't really matter. I'm going to put it here, and I know a squared is bigger, and I'm going to put a squared here. All right. So now, because it asked me to find the area under, not calculus, but the area under. So I'm looking for the area of this trapezoid. Well, how do you find the area of a trapezoid? 1/2 height, base 1, plus base 2. This is going to be my h, right? Because this is going to be base 1, and this is going to be base 2. So base 1 is going to be the height here, which is going to be your y value. Well, if x is a, and the equation is 3x, then what is the y value there? 3a. Well, that means base 1 is 3a tall, right? Same thought process for base 2. If x is a squared, then what is y? 3a squared. So the height, it goes up 3a squared. Not the height, but the height, but the base 2. Now across, how wide is that? What does it span? Well, I don't know, but to find the distance between the two, what do? Subtract them. So all you had to do, you didn't even have to multiply it out or anything of the sort. I did because I'm extra, but you definitely don't have to. 1/2 a squared minus a times 3a plus 3a squared. That's it. Can't combine them because they're not like terms. Does that make sense? Was it easier than you made it? Number 2 was intentionally there to trip you up, to make sure you knew all the properties of integrals. 2 cannot work because you can't split multiplication up. You can't do, it might equal, but it doesn't necessarily equal. It does not always equal. You can split up addition and subtraction, but you can't necessarily split up multiplication division. So 1 and 3 were the only ones that worked. It's not one of your properties. Your properties of integrals. Yeah. You just can't. Yeah. That was fine. Yeah. Oh, the glorious number 3. Let me show you how I did number 3. I did number 3 the way we did it in class. I said k equals the integral from 3 to x. Now you could have done Preston's way too, where you put them together and graphed it. I put, oh, that's right, this wasn't on calculator. Okay, so I put k by itself, right? Now what I'm going to do is I'm going to switch these bounds up so that I can combine them. And when I switch that bound up, I have to also, bless you, switch this sign. And a lot of you got to this point, but then you didn't know what to do from there. So this is now going to be plus x negative 1 f of t. This was a lot of manipulation of the integral itself. So this would be the integral from, well, if I'm going from 3 to x and then x to negative 1, then what I'm really doing is going from 3 to negative 1. But that doesn't make sense because my smaller number needs to be on the bottom, right? And so I'm going to go from negative 1 to 3, but change the sign. So really what I'm doing is the antiderivative. If f of x is 4x minus 9, then this f of t, the variable doesn't even matter at this point because there's no other variables on here. So this is going to be the antiderivative right? Or not the antiderivative, but the integral here. So I need the antiderivative. That's what I'm getting at. I'm sorry. It's 9, I'm sorry. What's the antiderivative? Oh. Evaluated from negative 1 to 3. Gray, you look like you're going to fall asleep. Okay, well, let's see what you do. Well, now we got to evaluate it. 20. All right, well, let's see. I got this negative that sits out front, so I'm just going to put that out front and ignore it for right now, and I'm going to plug in. So I've got 2 times 3 squared minus 9 times 3 minus 2 times negative 1 squared minus 9 times negative 1. I'm subtracting all of this, so I got to be careful. Negative 18 minus 27, negative 9, minus 2 plus 9, Does that make sense? Yes, ma'am.
If you got to the point where it was like, you know, the addition part where you could combine the two things. If it was subtraction,
Yes. You can do addition and subtraction, you just cannot do multiplication or division.
so, but if you do subtraction, would it be like a negative?
Yeah. Part B. Derivative of, remember, derivative and integral essentially cancel each other out, right? So all I'm going to do here, I'm going to take f of x, and in its place for x, remember it was, this is why I don't need an antiderivative. Now, you could do the antiderivative here. You could do antiderivative, you could plug in both bounds, you could go through and then take the derivative, but you're going to have a lot of work on your hands. The easiest thing to do here, and the point of this is part 2 of the fundamental theorem, and it says that I can take this, I can plug the negative 5x squared in here, but I have to chain it. So it's going to be 4 negative 5x squared minus 9, and now chain. You do the chain at the very end to the whole thing. You could have left it there Nope, you don't do anything because this and this are canceling each other out, essentially. The only thing you do is that bound up top. As long as the bottom is a whole number constant or is a constant value, no. So if you did multiply it out, you got 200x cubed plus 90x. Y'all good? I hope it seems a lot easier now. Like it seems like some of you didn't read the problems carefully too. Like me with the trapezoid rule when it said the midpoint. Number 4, make sure I didn't take off, but I did start writing the units on there. Make sure you do that because you'll lose your answer point if you don't do that. So get in the habit of that. The first one should be centimeters.
What about the second
Centimeters.
one? What about the,
Centimeters per second.
I knew I was gonna put that, but then I didn't think it was right. So I just didn't put that at all.
Oh wait, C is centimeters per second, D is seconds, and E is seconds. Everything is seconds except for C because that's velocity. Because look at what they're asking. They keep saying when. Oh, yeah. Dang it, y'all. Centimeters, A says what? What's the particle's position? So that's centimeters, and it's 0. Let me just give you the answers. B is position, so that's centimeters. C asked you for velocity, so that is centimeters per second. D asked you for, when is the acceleration 0? So that's seconds. And then E asks you when does it have its largest value, so that's seconds. Which ones do y'all need me to do of those, A through E? E, B, and C? Okay, everybody got A, right? What's the particle's position? You're just plugging into, you've got your 0 to T, S, or F. Okay. So from 0 to 0 is, of course, 0. Part B asked you, what is the particle's position at t equals 3? So I'm looking for the integral from 0 to 3. So if you look on your graph here, from 0 to 3 does this. This is 3. Nope. Yeah. It goes down. This is 3, 1. And you got this point 1, 2. This looks about like I estimated this to be 1, 2.5. So this is the area that you're looking for. Looks like a trapezoid. You split it up into a rectangle and a triangle. I did trapezoid 1/2. Distance across, of course, is 3. And then base 1 plus base 2. I get it. I have it look at my little long multiplication over here on the side. So 1/2, this will be 3/2 times, I should have left it as a fraction, it would have been a lot easier. Because that's 5/2 plus 1, which is 7/2. 21/4. Oh, just take your point, yeah. Part C asked you for velocity at 5. So what did I do here? Velocity at 5. This is the graph of velocity. So the velocity at 5 is -2 centimeters per second. It's Wednesday. If you don't need it, because I mean you're not retesting, you can leave it. I'll grab it off of there for you. Do what now? There's really not even any work to show for C. C is all about, do you understand that this is the graph of velocity? And so you're pulling that point. Same thing with D. When is the acceleration 0? Acceleration is 0 when t equals 5 seconds, because that's when velocity is at a minimum.
My estimation is where there's a point of inflection is that 10. Isn't that 10?
Okay, no, because point of inflection is where the concavity changes. You won't be able to tell. That would, yes, that would be right if this were the original graph. If this was the right. So since it's the graph of velocity, we need to say it's where the maximum or minimum occurs. So since that's a minimum and it's changing direction, that's why. Or you can say velocity goes from negative to positive. Any of those things work. Part E, what time during the first 7 seconds does S have the largest value? So if you look at the graph, because past here, this graph just kind of goes under the axis, right? So I'm looking for the biggest positive value. So up to, I just tried to kind of estimate where that looked like it was crossing the x-axis, because that's where the positive value occurs. So that's when it has the most positive. Does that make sense? So I want this point here, because all this area is positive. This is negative area, right? So I don't want to include that. So remember, my bug's moving to the right up until I hit that point, and then he's moving to the left. So I want to know when he moves the furthest to the right. So I put approximately 3.5 seconds because that's where the area has the most positive value. I figured you approximated. It's kind of hard to approximate on here. As long as you were close, 3.5, 3.25, somewhere in there. That's fine. Yeah, that's fine. That's where it's crossing right here. So as I truck along, once I get here and I start doing the integral, this is negative. So I'd start subtracting values. You see what I'm saying? And I want all the positives. So it has the biggest value here, because then it's going to start going negative. So if I had something that looked like this, when would it have the largest possible value? Well, it starts out going negative. So it's not going to start getting bigger until I hit the positive. So it would have the biggest positive value here, because this is negative, this is positive. The most positive area. How about 5? 40. You have to do the antiderivative, and you have to subtract, yes. Some of you did just the regular function that was in here, and then you subtract it, but you have to do antiderivative, and then you have to subtract. It's antiderivative, and then it's the antiderivative at the upper bound minus the antiderivative at the lower bound. So just that, and then plugging in the subtraction, and you should get 40. I remember yours now. You should definitely go up. And 6, if you didn't know your unit circle, 6 killed you. I don't know my unit circle as well as I should, but I did not pull it out because I did not want to be at any advantage over y'all. So let me tell you what I did. This is how I did it. I knew. I try to put the most common ones on here so you keep seeing them over and over. This is a very common one that they'll throw on there, a secant one. That for some reason, not cosecant, but secant shows up a lot. I know that this is the antiderivative. I know the antiderivative of this is secant x because secant x is secant x tangent x. I don't know why I remember that, but I do. Okay, so I'm going to do secant x from 0 to pi over 3, and then I went, crap, that means I got to know what secant is at those values. So I went, okay, secant is just the reciprocal of cosine, right? So here's how I reason through it. I'm still in the first quadrant. That's nice. It's nice to be in the first quadrant because they're easier to figure out. So if I'm in the first quadrant, this is 0. I've got 3 points I need to think about. Pi over 6 comes first, followed by pi over 4, followed by pi over 3. I always remember the bigger one comes first there. That's how I remember. Square root of 2 over 2 is easy to remember, but of course they're not going to give me that one because that would be too easy. So now I think. I know 1/2 and I know square root of 3 over 2. I just don't know which one goes where. I always get them mixed up every single time I do it. Which one of those two is bigger? Root 3 over 2. This goes further over, so the x needs to be bigger. This one's not as far over, so the bigger one is further up. That's what, like, I literally have that written on my paper here because I will stop and do that every single time because I second guess myself a gajillion times. Well, now 1 over cosine x from 0 to pi over 3. Cosine pi over 3 minus cosine 0. Well, cosine of pi over 3, well, now it's easy. Cosine pi over 3 is 1/2. So flip it. What's the cosine of 0? Well, that one's easy because this point is 1, 0. So what's the cosine of 0? 1. The answer was just 1. A whole 1.
I got that, but I got it wrong.
You'll fix it tomorrow. What? Antiderivative, yeah. That's what y'all kept forgetting to do is the
I literally
antiderivative.
almost had it right, but